So thanks to everyone for joining me today for this Jump for Institutional Research webinar. I wish we could do this as a conversation, so this is going to be a little bit tricky as I ask you questions and you can't answer right now. But one thing I'd like to ask is for everyone on this call, what is your job title? What sort of role do you have in your institution? And I do have a little bit of information on what your responses might be because you, when you signed up for this webinar, provided your job title. So here's a word cloud created in JMP of the job titles of people on this call right now. So it looks like we've got a lot of directors on the call, research analysts, people who use research somehow in their title, statisticians, some professors, and then a bunch of other scientists, people using developer or business in their job title. So we've got possibly a diverse crowd as far as the specific research questions you're working on, but certainly everyone who would have been drawn to this webinar is looking at questions related to institutional research, specifically at an academic institute. And then I'd like to ask, are these issues that you deal with in your job? Are you looking at data coming from many sources, maybe many different databases, and you're combining these data to get some insight? Are you looking at situations where there are duplicate records and you need to get rid of those duplicate records so that you're not overrepresenting, that you're not taking the mean of the same person over and over again? Do you have a large number of records that you need to summarize and possibly quickly? Are you getting requests? Maybe the state is calling and saying, I need a really quick turnaround on creating some summary reports. Are you looking for dashboards so that you can share interactive data summaries with other people in your institution or outside of your institution? Are you looking to find data insights from institutional data that you haven't harnessed yet? So you have all this data and you would like to see what else you can learn from it. And possibly we might also have people on the call who are looking for a point and click interface. JMP is a point and click interface that also has scripting in the background. So if you are a programmer and you love programming, you'll still be able to find your niche in JMP. Okay, and we're going to talk about how to do some of these kind of tasks that I assume come up in your job today. But really the important question is what could you gain if you could speed up your data management, your data exploration, analysis? What sort of things could you gain in your job from that? I think possibly if you could provide reports with accurate data, deduplicated very quickly in those tight time constraints, that maybe you'd be able to influence state legislature to fund certain initiatives or change policies to reflect the data in your actual institution. Maybe finding trends and telling a compelling story could help lead to administrative support of new data-driven initiatives, or improvements in student outcomes, or even profitability if you're a for-profit institution. And certainly student recruitment, enrollment, and student outcomes could be improved if we could identify underrepresented or under-recruited or under-enrolled, underperforming demographics, and we could target some kind of intervention to those groups. So the plan for this hour is we're going to do some specific tasks. We're going to create a summary report and a dashboard looking at student enrollment. We're going to create a map of enrollment. We're going to look at some text analytics. We're going to look at student course evaluations or student university evaluations to gain insight on trends. And then we're going to create a predictive model looking at cumulative GPA as what we're predicting based on characteristics or factors of students to see what influences GPA. And when we create that predictive model, we'll prepare that to deploy in another environment. So we'll create C or Python code from that we could deploy elsewhere. And we're going to do all of this for a very messy network of data sources. So these are the data sets that we're going to use. We have 4 distinct data sets. One is a JSON file, a couple of them are Excel, one of them is a CSV.dat file. So let's explore these for a moment. So the general student information has 9,005 distinct records. So there's 9,005 unique students in this data set. And we have 7 columns of information in this particular data set. We have the ID for the student. We have, are they male or female? We have, are they first generation or not? We have their zip code, where they came from when they started became enrolled in the school. We have, are they Greek or not? In other words, were they involved in a fraternity or a sorority while they were at the university or not? Did they get a job within 6 months of graduation? And if they did get a job, what was their starting salary? We're also going to pull in term student data. This is a much larger data set that has 40,366 records and more columns of information that are specific to a specific course in a specific term. So you can see at the top of this data set, there are 4 rows that start with the number 1000. So these are 4 rows that correspond to the student with ID 1000. And you can see the additional information we have is the year that they took the course, the quarter that they took the course, what their grade was, what their term GPA is, what their cumulative GPA is. So these records, what we're going to do today during this hour is we're going to try to deduplicate this. We don't want multiple records per student. We actually just want the last record per student, the last time they were enrolled in the school. So I'll show you at the end of this, as we do some data management, how to get those deduplicated data. And then we're also going to join in some information about the state of Florida. So I'm assuming that these hypothetical students, and none of this data is from real students, I'm going to assume that they live in the state of Florida. And so the zip codes that are assigned in the student data, I'm going to match them up with just some general population information about Florida. And the last data set that we'll join is just 50 records. So we sampled just 50 students and asked them for a review of the university. So then the last data we'll pull in is just 50 records matching up with student IDs from that larger data set and looking at their text review. So at the end of this, I'm going to show you that in just a couple minutes, we can pull all those disparate data sources together really quickly. But before we do that, I'm going to show you some flashier things because I think it's going to be more exciting. So I promise you the spoiler at the very end is in a couple minutes, we're going to be able to pull all those data sources together. But right now, I'm going to start with the final data set. You can see there's 9,005 rows in this because there's the 9,005 unique students. And then I have all of the columns pulled into this data. So I have the population for the states into this data set. I have all of the term information from the last term that the student was enrolled, their general information like their sex, their first generation or not, etc. Okay, and then these are the things we're going to do today. We're going to create some summary reports and pull them into a dashboard. So you can see in this dashboard, which we're going to create today, that I've got some information on how many students or proportions of students that are first generation or not, whether they were in a Greek society or not during their time in university, whether they got a job within 6 months of graduation or not, what those starting salaries were if they got a job. Then in the second panel at the top, you can see a Mosaic plot that's showing visually the proportions of students that got a job within 6 months compared to whether or not they were Greek. So we can see from that Mosaic plot that if you are Greek, the blue groups, you have a better chance of getting a job within 6 months. So maybe that networking within your fraternity or sorority is really helpful in job placement. And at the bottom, on the bottom panel, we can see the average cumulative GPA over the years of graduation. And we can see this split out for first generation students versus not first generation students. So we'll make a dashboard like this. We'll also look at a map of the proportion of first generation students that are being enrolled from different zip codes across Florida. We'll look at some text exploration of that text data. So here we can see in the word cloud at the bottom, the words that are commonly used in those reviews of universities by students. And you can see that they're colored by the starting salary. So the redder the word, the higher the starting salary of the students. So we can see that students with high starting salaries said things about their university like school or class or college. That doesn't tell us very much, but they also said words like expensive, difficult, whereas the students who had lower starting salaries said some words like online shows up there. So possibly the lower salary students were in online programs, which would be a very interesting finding. We might want to target an intervention in that case and help support our online students. And then the final thing we'll do is to create a prediction model, in this case for cumulative GPA, and we can base that on a number of factors. So here we're seeing at the bottom a visual of the year, the sex, whether or not the person is a first generation student, and their final term GPA as predictors of their cumulative GPA. So you can see for the particular factor settings that are marked by those little red crosshairs, we can see that someone who graduated in 2008, who was female, who is first generation and had a 2.0 for that final term, their predicted cumulative GPA was a 2.44, and we see a confidence interval on that prediction. So we'll create a prediction model like this, and we'll generate some code in order to score this in another, in any kind of platform. Okay, so let's hop into the software. I'm going to keep this plan for the hour up in the corner so we can keep checking back and make sure that we're covering the things I promised to talk about. And here's the deduplicated data. So here's the 9005 observations with all the variables joined into the same data set. So the first thing I do when I pulled data sets together, created my single data set that I want to use for analysis, is I want to do a little quality checking on the data. And one tool for this is up here in the JMP menu bar. The Analyze menu has a lot of analytic tools, including a simple one called Distribution, which lets us just look at distributions of one variable at a time, so univariate distributions. So if I click on Distribution and select some variables, so I might, for example, look at year and quarter and sex and first generation student, I can click this Y button to put them here, that this is what I want to analyze, or I can drag them in. I just say OK. And I see some statistics and some plots, some visuals about these data. You'll notice if I click on something, so I'm going to click on this 2013 bar, you can see that JMP ties all of these outputs together. And so the 2013 data are highlighted in the other plots as well. So I can see that I didn't have any fall graduations from 2013 because my data cut off at in this case, in winter or spring, whichever is the last, would be the last spring. It ended in spring of 2013. If I want to show this all on one page so I don't have to scroll down, these red triangles in JMP allow you in the context that you're in to find more options. So if I go to the top red triangle, that's usually where I'll find more options for how to visualize something. In this case, I could choose this arrange in rows and ask to put 2 analyses across each row so that now I can see this more clearly on one screen. I can also notice if I look at sex here that I have 2 categories for female and 2 categories for male. So distribution is a great way for me to do some data cleaning because I can really quickly see if I had coding errors. In this case, I introduced these coding errors so that I could show you this, but I have female coded with a capital F 1990 times in the data set, but once it has a lowercase f. And male is coded correctly with a capital M 7,013 times, but it's misspelled 1 time. So this might spark to me that I need to go back to the data table and recode sex. So to do that, I go back to the data table and I go to the columns menu because I want to recode this column. So we hope that in JMP things are in an intuitive place. If I want to do something with a column, I go to the columns menu. If I want to do something with a row, I go to the rows menu. If I want to do something with a table, like join a table with another table or split something out or take a subset, I choose the tables menu. So here I'm going to the columns menu, choosing recode. I can see that lowercase female here. I want to change that to an uppercase female. So I'll just edit it over here and click off. And you can see that JMP is now going to take those 2 female categories and combine them into 1. I'll do the same thing for the misspelled male. Click off of it and you can see JMP takes both of these and combines them into 1. And I can just click done here and say in place, and it will replace those values right in that column just where they are, just make that correction. Another option is to put them in a new column, just in case I'm worried that I'm changing something I don't want to change. And a third option is to make a new formula column. I'm going to choose this option. This gives me a new formula column at the end. I called it sex2. And if I double click on this, you can see that it applied a formula. So now if I add any rows or update any rows in this data table, JMP is going to look at the original sex column. If it sees lowercase female, it's going to change it to uppercase female. If it sees this misspelling of male, it's going to change it to the correct spelling of male. And otherwise, it's going to use whatever was written in that original sex column. So this allows me to apply this formula to any updates that I make to this table. Okay, so we kind of explored some things. One other way to explore data is to look at tabulate, which is making tables. So if I go to tabulate, I have these drop zones where I can make tables really quickly by dragging and dropping variables. Let's say I want to look at the proportion of first generation students or the counts of first generation students across the years. So I'm going to drag year down here into this drop zone for rows. You can see that it highlights a blue line around the drop zone while I hover year over it, or other places if I drag around. So that lets me know that when I let go of this, it's going to land there. So if I let go of year, I can now see just the overall counts of graduations per year. And if I now take first generation student and move it up here, there's still a drop zone. It doesn't look quite like it did before, but there's still a place for me to drop this. So I'm dropping first generation student here, and it's telling me I'm going to take the sum of this column. This is because right now, first generation student is coded as zeros and ones, and it happens to be treating them as continuous. The way I can know this really easily in JMP is if I look at these icons on the side, the blue, red, and green icons. The blue triangle is indicating this is treated as continuous right now. Sex, on the other hand, is also coded as zeros and ones, but those are being treated as nominal categories. And actually, sex may have been coded as males and females. What's another one? Greek. Greek is definitely coded as zeros and ones. So if I clicked on these icons on the side, like on first generation student, I see the options. Right now it's being treated as continuous. I can change it to nominal and have it be treated as nominal now. Now sum is not going to be an option. I'm going to pull this back off. Now I have the number of no's and the number of yeses. So JMP is very context dependent. And if you have something continuous, it's going to give you the kind of options that make sense for continuous data. If you have something categorical, it'll give you the kind of options that make sense for something categorical. And here, if I want to put some other things like maybe the percent from the row, what percent in 2001 were no and what percent were yes, I could take the row percents. And if I want the counts as well, I'll drag that back on right in front. You can see I'm prepending this. So now I have the N, the number in that year, and what percent. So I can see in 2001, I had 668 not first generation students, and that was 80% of my data. And I had 160 first generation students, and that was 20% of my data. When I'm happy with something, I can click done. And I have a lot of ways to take this out of JMP. I can click on this fat plus sign and just highlight it and copy and paste it into a Word document or PowerPoint slide. Or I can choose the file menu and either use save as or export to take this out as, for example, an image file or directly into Microsoft PowerPoint. So JMP tries to make it really easy for you to create great visuals and then take those visuals to wherever you need to show them. Okay, so let's create a summary report and make a dashboard out of it. If I go to Analyze and back to Distribution, let's look at a distribution of first generation and Greek and job within 6 months. Let's see, where's that one? And the starting salary. And I'll put those into Y and say OK. Again, I'm going to go to the top red triangle. I'm going to ask to arrange this in rows to make this a little easier to see. And this time I'm going to make it even simpler. I'm going to take out all of this extra statistics information, the quantiles, the frequencies. You can see here for starting salary, because this was continuous, I have summary statistics like the mean and standard deviation. I have quantiles. Whereas for the categorical variables, I have frequencies and counts. So if I want to remove that and make this a little simpler to put into my dashboard, I can use the red triangle for each variable, and I can ask to uncheck some of the things that are being displayed. So here, display options, if I click on frequencies, that goes away. If I go to display options and click on frequencies. So I can easily edit what's shown. Here, if I wanted to take away the quantiles, if I want to take away the summary statistics to make this as simple as possible. Now I just have this interactive output without the summary statistics written. So I'll save this to put in my dashboard. Now let's make that mosaic plot I showed you before. So when I look at this, I can see that if you are not Greek, getting a job within 6 months, seems disproportionately in the no category. Whereas if you are Greek, if you did belong to a Greek society, you are disproportionately more likely to get a job. So I can see the trend here visually, but I may have the question, is that a statistically significant difference? Is there really something going on statistically? So I might go to analyze. And the next most complicated step here is fit y by x. This is when I have one x variable, one y variable. And that's what I have here. I want to use Greek to predict whether or not I have a job within 6 months. So fit y by x is a great place for me to go to answer that question. I'm going to use Greek as my x, and I'm going to use job within 6 months as my y. Say OK. And so here's that mosaic plot that I saw before. You can also see now when I have multiple pieces of output open in JMP, they're all interacting with each other. So when I click on a box in the mosaic plot, that data gets highlighted in the other distribution output as well. We can also see that, in fact, the answer to the question, was there a statistically significant difference in job within 6 months if you're Greek versus not Greek? The answer is down here. Let's look at this test with this p-value here. The right-tailed test has a very tiny p-value, much less than 0.0001. And this is saying that the probability of a job within 6 months happening, yes, is greater for Greek yes than no. And that's the one that has a significant test. So we're able to reject the null hypothesis and conclude this alternative hypothesis. So we can see, yes, there does seem to be a significant trend. I might use these gray arrows to hide away some of this output again to make this simpler. And then I'll just save this to the side. And let's make one more thing. Let's go now, so we've looked a little bit in Analyze. Let's look at the Graph menu. In Graph Builder, I again, just like Tabulate, have drop zones. It's again a drag and drop sort of platform. So in Graph Builder, let's look at the year along the x-axis. You can see as I drag things, JMP makes some guesses about what I might like. So right now it's giving me a bar chart of the count of the number of people who are graduating in each year. But I want to look at the cumulative GPA over those years. So I'm going to take cumulative GPA and drag it into the y-axis. Now I've got these box plots instead of the bar chart. If I want to choose something else instead, like if I want to connect the means of these groups, I can drag this on top, or even click on the box plots again so that they'll be removed. So I can easily use this ribbon at the top to choose different ways of displaying my data. So if I want to look at connecting the means for each group, but maybe I also want to put error bars on this. I have error bars where I could look at the entire range of the data, or maybe the standard error. I'll choose the standard error here. So now I'm seeing in 2001, here was the mean, and here's one standard error on either side. And then let's split this out for first generation students and not first generation students. So I'll drag this into overlay. So it overlays the two plots on top of each other. And if I'm happy with this, I can click done. And this was the third, oops, I'm clicking on something. This is the third piece I want to put in my dashboard. So these are now the 3 elements I want to add to a dashboard. When I want to create a dashboard, I go to File and New. File New is where you'd create any new JMP element. So if I wanted to make a new data table, I'd find that here. A new script, if I'm using the scripting language in the background. A new journal, which is a place that you can sort of save reports. A new application. A new database query. A new add-in. But here I'm choosing a new dashboard. And we get some options of templates. I'd like to put 2 things on the top and 1 on the bottom. This template's pretty close to what I'm looking for, so I'm going to click this one. And I'm going to just drag these into these spots. So I'm putting the distribution in, I'm putting the contingency table in, I'll skip this one, and I'll put the graph builder output at the bottom. And then all I have to do is click this Run Script button. This is like make the dashboard. It'll take just a second. And now it made the dashboard. There's a couple things I still want to change. I'd like to move this up a little bit. Well, let me try this one first. So the top red triangle over here will let me change the report view to a summary, which will take out some of that extra space. And then let's try to shrink this still. So I have lots of editable features. You can see I'm just kind of grabbing things and dragging them to resize them. So when I get this looking the way I want and I'm happy with it, I can save this dashboard. One way I can save this dashboard is as HTML5 code, so I could put this on a website or send it in an email and it would retain that interactivity. So again, as always, with any report in JMP, I can go to File to either Save As or Export and find that option of Interactive HTML with Data. That's going to have the data in the background, and you want to be very careful if you've got student data not to put this somewhere public because the data are attached in the background with this HTML5 code. But if you want to share something internally and you are able to share that with data, it will retain that interactivity if you share it in that way. Okay, I'm going to clean things up a little bit. So we did this first item. We created a summary report and a dashboard about student enrollment. Now let's look at a map of enrollment by the Florida zip codes. So again, I'll go back to Graph into the Graph Builder. And when I want to make a map, there are several ways I can do this. One is if I have GPS coordinates or latitude and longitude, I can drag them into X and Y, and JMP will create a map. Another option is if I have a column in my data table that JMP recognizes as I know what those shapes look like. If I have a column like country names, so if I have the United States, Italy, Kenya in a column, JMP is going to be able to recognize those and know how to make a map. Or if I have the state names, the US states. Another option is zip codes, and in this case I have the zip codes. So I'm going to drag this zip column, which is just zip codes, into this map shape little box down here. And when I do, JMP makes me a map of the state of Florida. Now I don't have any variables being represented here yet, so one thing I could do is just look at what's the total population, what are the areas of dense population. I can drag this on top of the map, or I can put this over in the color box to get the state map colored by total population. So I'll just drag it in the middle. It's the same as dropping it here. So you can see the high population areas are in red, low population are in blue, and middle is in gray. I don't love this kind of diverging color scheme for something of this nature, so I'm just going to double click in here, click in the color theme and choose something sequential, like maybe this green. So it'll be white if it's low and dark green if it's high. I'll say OK. So now the dark spots are the areas of high population. I can use some of these tools up here to see this better. If I use the magnifier, I can look down in the Miami area and I can see these counties. So high population but tiny area. I can also undo this. And when I'm happy with my map, I can click Done. I can use that fat plus sign to just save it out as an image, copy paste it out, or I can use File and either Save As or Export to save this in a number of different ways. If I want to go back and edit again, I can use the red triangle to select that control panel back. And maybe I'd actually like, instead of just looking at the total population on this map, I'd like to look at the percent that are first generation. So I want to look at the proportion of first generation students. We have a couple of options because this was coded as 0-1, but is being treated as categories. Let's try dragging it on first with this when it's being treated as categories. So if I drag this into color, you can see that it colors it blue if there are first generation students who are not first generation, and it colors it yes or red if it's yes. And so you can see when there's both groups, it turns it some kind of shade between blue and red. So this actually does give me a sense of the proportionality in different areas. This county here only had yes, and the purple counties have something in between no and yes. Another option is for me to, again, change the first generation student to continuous, so it's zeros and ones. Now, if I take a mean of that for each county, that's going to actually just be the proportion. So if I drag this on top, now these are colored by 0% to 100% of the enrollees were first generation students. Again, I don't like this color scheme, so I'm going to change it. Maybe I'll use that green again. So now we can see this county down here. It's row 6,786 in the data set. And the mean of the first generation students is 1, which means all of the students that came from that county were first generation students. But it's only one row. So there was only one student, and that student happened to be a first generation student. Whereas this county above has 23 rows, so 23 students came from this county. The average is 0.35, so about a third of them were first generation. So I may not want to show all the counties that have just one student because that's going to weirdly inflate. It'll be either 100% or 0%. So this may be a time, I'm going to click done to make this look a little simpler. This may be a time to apply a data filter. Data filters are available on any type of output from JMP. From the red triangle down at the bottom, I can apply this local data filter where, for example, I'm going to use this N in zip. This is the number of students that came from each zip code. So I'm going to add this variable as a filter. Right now it's saying, okay, each county had either anywhere between 1 and 36 students enrolled from that county. So I can use the slider scale to move this up. So now I'm only looking at counties that had 8 or more students enrolled from that county, or I can even click in this box and say, let me change this number to 6. So now I'm looking at the counties that had at least 6 students enrolled. So now I can see better, I'm excluding the counties that had just 1 student enrolled or just a couple students enrolled. So I can use the slider scale to apply this local data filter. Again, this is available everywhere in JMP. So you could run a regression, for example, and then decide that you want to filter out certain observations and see how the regression model changes. All right, so we've done the second thing, create a map of enrollment for the Florida zip codes. Now let's explore some text. We're going to look at its student evaluation data on the university. So if we scroll, where is that column? So here's the text review column. We only sampled 50 students. We only asked 50 students what they liked about the university or for a recommendation or to give some feedback on the university. So I may want to make a subset of my data before I explore it because I've got so much missing data here. So this data set is large. It may make more sense for me to make a subset first. If I want to do that, one option is I want to just select all the rows where there's text data where it's not missing. So if I want to do that, I can go to rows and I can do a row selection. I want to select certain rows and I want to select rows where they meet a certain criteria. So this is an easy way for me to quickly just select certain rows and then make a subset of those. So I'm going to select where. I want this text review column to not be missing. So what I've got here is basically a sentence. I want to select all the rows where text review does not equal missing. And missing, I just don't put something in that box. So I'll say OK. And now you can see down here in this rows panel, you can see that I have 50 rows selected because those are the 50 that were not missing. And so you can see that's row 68 is selected because there's a text review. Row 124 is selected because there's a text review. Now I can go to tables and subset. I want these selected rows. I don't have to change anything. I just want to keep the selected rows. I say OK, and now I have a subset that contains just the 50 rows. It has all the columns, but just the 50 rows with text data in them. So now I can really quickly see the text reviews here. So that was just a little cleanup to make this simpler to look at. Now I'm going to go to Analyze and choose Text Explorer to explore that text. So in Text Explorer, I choose the column that has the text. I put that into this box for text columns. And I'm just going to say, OK, I'm going to keep all the defaults here. So here's the first output I get. I see the commonly used terms. So the word school was used 31 times. If I want to see what those times were, I can click on school and right click, and I can show the text. Now I see row 7 said I do recommend this school. Row 10 said I would recommend this school. So I can see all those instances by just right clicking and asking to show text. I can also, so this bang here, this is the exclamation point. This is just, did an exclamation point show up? So 20 of the reviews, or 20 times exclamation points showed up. So if I want to exclude this, if I don't want to include the exclamation point, I can click add stop word, and that's going to remove this from the analysis. And then if I want to make a word cloud to see what's really going on with a visual, I can click the red triangle at the top, choose Display Options, Show Word Cloud. So here's the word cloud at the bottom. I'm going to make this a little smaller. And there's options here with the word cloud for me to change this and make this look the way I want it to. So for example, the layout, I could center this. This is still interactive the same way this list is. So again, if I click on school and right click and show text, it shows me all the places that school shows up. Let's see, all the places that expensive shows up. So living on campus is expensive. The school's a little expensive, but worth the quality. Another option for visuals here, I can change the coloring. You should have seen something that looks a lot like this at the beginning of this webinar when I showed you the word cloud of the job titles of people attending today. So arbitrary colors just makes it look kind of flashy and pretty, but doesn't mean anything. Another option is to color it by column values. If I do this, the example I showed you at the beginning and that we're trying to recreate right now is if I colored it by salary. So if I color these by the starting salary and say OK, now the redder the word, the higher the starting salary of the people who said these things. The bluer the word, the lower the starting salary of the people that said these things. So we can see if we can find some insight in, did students who had a certain perspective of the school have higher salaries? Is there a different perspective for higher salaried students than for lower salaried students? And let's see. So we did notice that the word online is bluer. So online students, there were only 10 observations that said the word online in their review. So this certainly is not a very large sample size. We'd want to do more research on this, but it looks like for this particular university that students who were talking about the online program in their review had lower starting salaries on average. Okay, so we've looked at a summary report and a dashboard. We looked at a map of enrollment. We explored a little bit of text to look at some insights. And now let's create a predictive model. Let me show you something else we can do with text in the context of a predictive model. So let me reopen the Text Explorer. I'll put text review back into text column, say OK. Another thing we can get from this top red triangle menu is this Save Document Term Matrix. If I click on this and I ask, let's say we just save the top 10 terms, and I'm going to just let the defaults be here, so this is binary. What happens is I save out indicator variables of, was this word used in that particular text review? So this person, row number 7, said the word school in their review, but did not say the word good, for example. And this person said the word school and did say the word good. And this person said the word school and had an exclamation point, but didn't say the word good. So we can now, by saving out these indicator variables, we can use these in a predictive model. So let's create a predictive model here just on this small subset of data. I'm going to go to Analyze. I have some things that are labeled as predictive modeling. Some of these are only available in the JMP Professional version, JMP Pro, and a few of these are still available in JMP. So I could be using neural networks, partitioning, a bootstrap forest or a boosted tree, k-nearest neighbors, naive Bayes. These are a lot of predictive models I might choose to use, especially if I want to compare them to each other. Right now, I'm going to just use a simple fit model. So what I'm going to show you is available in JMP, not just JMP Pro. And I want to predict the cumulative GPA. So I'm going to put that into the Y. And then I'll put all my X's down here into this construct model effects box. So let's use the first generation student. Let's use, and I'm going to change this back to categorical. So I'll call these nominal again. We'll use first generation student, we'll use Greek, and we'll use their interaction. I can click on things one at a time and click the add button or drag them over here. But I can also, to speed things up as I'm entering terms in this model, I can use this macros button. Here I want both first generation student, Greek, and their interaction. So if I click this full factorial, I'll get all three of those really quickly. So here's first generation student, Greek, and the interaction of those two things. And then let's also add those words, the indicator variables for those 10 words. And we'll just make this our model to predict cumulative GPA. So I'll click Run. We see a lot of output. This output here, the effect summary, this is showing me that the first generation by Greek interaction is the most significant term in the model. Greek is the next most significant term. And it looks like college and classes are borderline significant, and none of the other word terms are particularly significant. One of my favorite features in JMP is to create the profiler. So I'll go to the top red triangle and ask for factor profiling for profiler. This shows me a visual picture of what's really going on in my model. So this shows me that if the student is not first generation, didn't get involved in Greek life on campus, and then let's say did say the word school in their text review, did use an exclamation point, did say the word good, but didn't say any of these others. So for this particular person, a person that falls into these categories, their predicted cumulative GPA would be a 2.52 with a pretty wide confidence interval. So this is not an especially predictive model. I might want to rerun this model without some of those effects and just focus on the interaction between the first generation student and Greek and maybe use one or two of these word terms. But when I have a model that I like, a feature in JMP Pro, so what I'm showing you right now is specific to JMP Pro, is that I can go to the red triangle and in Save Columns, I would have the ability to save a lot of these things out in JMP. But one thing that's unique to JMP Pro is this Publish Prediction Formula option. Publish Prediction Formula, if I click on it and then I select the top red triangle, this is where I can generate the scoring code in any of these other languages. So I can generate C code, Python, Java, SAS, SQL. So let's look at the Python code for this particular model. So you can see that you could create the model in JMP, and if you need to deploy it somewhere else, you can automatically generate the scoring code for that model. So this is a pretty awesome feature, but again, available only in JMP Pro. You can create these predictive models in JMP, but you can't generate that scoring code automatically or use the formula depot, which is pretty powerful for predictive analytics. Okay, so we talked through the 4 things I wanted to show you. We looked at a summary report and a dashboard about student enrollment. We looked at building a map and looking at enrollment across that map. We filtered based on the number of students that were enrolled per those zip codes, so we were able to apply a data filter. We looked at some text evaluations. We even used some of that information to create a predictive model, and we looked at how to deploy that somewhere else by generating the scoring code. Now let's go back and look at how easy it is to take all your disparate data sources and pull them into one place. So I'm going to close some things and make this simple. I'll save this and close it. And here's our data sets right here. So we had 2 Excel data tables, this Florida zip population, the student reviews. We had this JSON data table, and we have this .dat CSV data table. So we can start with just the simple Florida zip population. And if I right click on this, because I've already got JMP installed, JMP is an option to just directly open this Excel file. So one really easy way for me to get this into JMP is to just open it in JMP 13. It gives me an Excel import wizard. So if I didn't have the column names or column headers in the first row, I can click this. So I can make sure that this looks the way it's supposed to and then click import. Now here it is as a JMP data table. I can do the same thing for the student reviews Excel dataset, where I just right click and just ask directly open it right away into JMP. Again, I have column headers. That looks right, so I'll say import. I can also do this for the CSV type file, the .dat. So I'll open this directly into JMP. And then for the JSON, I'm not going to have the option to open it directly into JMP, so I'll open it from within JMP. So here I am inside of JMP. If I go to File and Open, I can find that general student info and click Open, and there it is. So there's a lot of ways to pull data into JMP, but as you can see, it's pretty direct. So either finding JMP as an option to open a data file, a lot of things will open natively, or using the file open as the way to bring data in. A lot of data files will open really easily within JMP. Worst case scenario, you can always save something to a CSV file and then read it into JMP, but I really think you're not going to run into problems of data files not opening well in JMP. So now once I have the data files open in JMP, I can use the Tables menu to join them together. One option is pretty straightforward. It's the Join option. So I can join data tables by just using this Join option. Another option is this JMP Query Builder, which I'll show you. It's going to join things a little bit quicker. So if I start with, let's use the largest data set. Let's use that term student data, the one with 40,000 something observations, as the primary data set. And then let's join it with the other 3 data sets. You can see that JMP had no problem figuring out what to do with the student reviews and the general student info and how to join it. It gives me this picture and it says, yeah, I found the key. I can tell that you're going to combine these based on that ID for the students. So JMP automatically figured out how to combine the student reviews, the general student info, and the term student data. But there's a little red X here telling me it didn't figure out what to do with the Florida zip population file. So if I just click on this and edit that join, I can now see that what I want to do is I need the zip code to be what I'm matching on. So I need to find the data set that has zip code in it. That primary data set doesn't have zip code, so let's choose the general student info, which did have zip. So now I can say I'm going to use zip from that secondary data set, match it with zip from the Florida zip. I say next and OK. And so now I have the ability to join these directly. I can preview the join and see this is what the data table is going to look like. I can click Run Now to just have this run directly and make me this table, or I can click on Build Query if I'd like to explore this a little bit more. Maybe I want to filter before I bring the data in, so I can click on things and apply filters. I can also look at the SQL that's generated from this query. So there's a lot of things I can do here in Query Builder that make it a lot easier for me to bring data in and to recode, or not recode things, but to filter things out and bring in only the data I want. So let me go back to let's open it one more time and I'll show you just the easiest direct way to do this. So again, I'm going to use this term student data as the primary data source. I'm going to use the other 3 as the secondary data sources. I can see the red X tells me this didn't work, so I just right click it, I edit. I know that the key was in the general student and it was the zip. I combine that with zip here. I say next, OK, click Run Now. And that's it. That's all I needed to do. So now I have the data table that's got the 40,000 rows. The other tricky thing I did before we looked at all these analyses was to deduplicate. To deduplicate this, I wanted to sort, first of all, by the ID. So we can see the first 4 rows are the same ID, the next 5 rows are the next ID. So it already is sorted by the ID. If I hadn't sorted it already, I would go to Tables and Sort to do this, and I'll show you that in a second. After sorting by ID, I next want to sort by year and quarter, because what I actually wanted, the way I'm deduplicating this data, is I only want the last observation in time for each ID. So if a student, the last time they were enrolled was 2001 in the fall, that's the only row I want to keep. So if I can order these descending so that the last observation lands on the top, that's going to make this really easy for me. So if I go to Tables, they're actually already sorted this way, but if I go to Tables and Sort, I want to sort by the ID, then I want to sort by the year, then by the quarter, but I want the year to be descending, so the later years at the top, and quarter to be descending, later years at the top. I say OK. So here's my sorted data table. It's actually identical to the other one. And now the tricky thing I used to save me just a couple of extra steps is I used an add-in. If you're doing a lot of this type of data manipulation, this is an add-in you really want, and I'll give you the link to find this. So this add-in, an add-in in JMP is kind of like an R package would be in R, or any kind of contributed, you're writing a little bit of script or doing some point and click things and then packaging them together. So add-ins can help you use JMP a little bit more efficiently for specific things. So in this case, I'm using an add-in called Data Table Tools, and I want to use this special formula columns where I want to number the rows within groups. I want to get the number 1, 2, 3, 4, 5, 6 within each ID so that I can exclude everything except the first one. So if I number rows within group, I'm using this data table that's calling itself Untitled 180, and I want to label them within the ID. So I'll create a column that numbers. So for rows 1, 2, 3, 4, it's going to give me number 1, 2, 3, 4. For 5, 6, 7, 8, 9, it'll start again 1, 2, 3, 4, 5. So I'll create the column, and then we can see the column at the end. So the first 4 rows were the first, second, third, and fourth instances of person with the ID 1000. The next 5 rows were 1001. The next 4 rows are the next ID, then 2 rows are the next person, then 2 rows are the next person. And I only want to save out the first row for each of these people. So to do this, I can go back to rows. I want to just select everything where there's a 1 here. So I go to rows, row selection, select where. And I want that last column to only be a 1. So I can say OK. Now I just have the 1 selected. And then I can go to tables and subset, just keep these selected rows, say OK, and now I have a subset with just the 9,005 observations. So that took less than 5 minutes for me to pull all my data sets into JMP, to join them, and then to deduplicate based on the last observation for each ID. I hope you'll find that this is really helpful and time saving and gets you to data that are much cleaner. Because again, what if I presented summary statistics where each person in my data set was being averaged multiple times into my statistics? That's not accurate. So we want to make sure that you have the tools you need to analyze data correctly and to get there really fast, and then to be able to use these really awesome tools to explore your data, to find new patterns, to create great visuals that tell a story, and hopefully really help you in your job and at your university, to make your university as great as possible, to help you with student outcomes, with faculty outcomes, and when possible, to make a little bit of money in the process. So again, thank you so much for joining me today. If you have any questions, we've got about 6 minutes left for the webinar, and I'd be happy to take some questions. So just type them into the chat or into the Q&A, and Julian will pass those questions on.